Welcome back, guys. We've got a few more activities to get through. So let's not waste any time. Let's get straight to it. Have a look at this question. It says, we're given a list of events. There are 5 events in total, and it's all to do with rolling a dice. And from this list, we need to select a pair of events that are going to be mutually exclusive and complementary. Well, that's quite an interesting thing. So let's just make sure that what we've got here is very clear. So the first thing is, if we were rolling a dice and we got even numbers, well then it would be 2, 4, and 6. If they were rolling odd numbers, then we would recognize that those would be 1, 3, and 5. Now, if we look at just those two, we recognize there's no common intersection between them. If you're an even number, you can't be an odd number. So then we are mutually exclusive. And in the total set, we would recognize there are only 6 possibilities. And so if you're not in the one set, let's call it A, then you would have to be in the second set. And so that was what we mean by mutually exclusive and complementary. But let's have a look at what the Venn diagram looks like. So if we look at A and E as examples, we'd recognize that A was all the even numbers, so we had 2, 4, and 6, and E was all the odd numbers, and we'd recognize those were 1, 3, and 5. Now, we recognize there's no overlap, so we definitely can say they're mutually exclusive. And because they're mutually exclusive, we can apply the addition rule for mutually exclusivity. But we wanted them to be complementary as well. And that means we've got to check that does the probability of A equal to the probability of 1 minus the things that are not in A. That will tell us if they're complementary. Well, if they're not in A, then they're in E. And what we'd recognize then, if we fill in the numbers, we can say that this is 1 minus 3 out of 6, which is a half. So the total is a half. And what do we know about the probability of A? Well, the probability of A is exactly that. It is the total number in A, which is 3, divided by the total number of outcomes is 6, so it's a half. So we can therefore say that these two outcomes, set A and set B, are both mutually exclusive and complementary. Now, you might want to look at those options and recognize that there are others that are mutually exclusive, but they're not necessarily complementary. They don't mean that you can take the two sets and add them up to give you the value of 1. That's what we're looking at when we look at complementary and mutually exclusive. Right, let's move on to our next one. In this case, we're given a less demanding one in a sense. We're saying, let's choose B, which is rolling a 3 or more on a dice. So remember, that's 3, 4, 5, and 6. That's 3 or more. This one, C, says less than 5. So if it's less than 5, then it's 4, 3, 2, and 1. We have to look at the OR rule here. So let's draw a Venn diagram and use that to calculate. I've gone ahead and put some figures on the board already. And remember here, we're looking at the OR rule. We recognize that these are not mutually exclusive. And because they're not mutually exclusive, B, C, the probability of B or C is equal to the probability of B plus the probability of C minus the probability of the intersection of B and C. So if we have to do this calculation, we'd recognize the probability of B is going to be, there are 4 out of 6. So this is 4 out of 6. And the probability of C is also 4 out of 6. Now notice, because we've done that, we've counted the 3 and the 4 twice. So we've got to subtract those in the intersection. And that's what I'm going to do here. We recognize that the intersection has 2 elements out of the 6, so we subtract those. And if we get the totals there, we recognize this is going to be 8 out of 6 minus 2 out of 6, which gives you 6 out of 6. And that's exactly what we're hoping to get, because all the elements in the sample space exist within the combination. And so the probability of getting B or C is 100%. Very good. Now, the last thing we're going to ask ourselves is, are these events independent? And we have to be careful when we're doing this independent calculation. So let's just make sure that we've got the calculation over here. We recognize where the sets are, and we want to make sure that we're going to calculate the probability of B and C. Now, what's the probability of B and C? Well, it's this here. We can recognize the probability of B and C. We calculated it over here. It's 2 out of 6, which is 1/3. And what we recognize is that we have got 1/3 as the intersection. Now, if they're independent, then what we should be able to do is to recognize that the probability of B multiplied by the probability of C is going to be equal to 1/3. But is that the case? Well, let's have a look and see. So if we take the probability of B, recognize the probability of B from that calculation over there is 1/3. We take a look at the probability of C, recognize that's 1/3. Now, what's the product of those two? If we say multiply them together, that's 1/3 multiplied by 1/3. Can you see that's going to give us 1/9? And in the intersection, we only had 1/3. So these are not independent events. That's the test. We can recognize that these are not independent events. Right, guys, I think that's more or less brought us to the end of our questions. Let's just do a quick sum up. In today's lesson, we've looked at the fact that you can use Venn diagrams to represent 2 or more events. We've also spoken about complementary events, where we've recognized that to find the complement of something, the complement of A is equal to 1 minus the probability of A, the probability of the complement. We've also recognized mutually exclusive events. Remember, there is no intersection. The intersection, the number of elements in the intersection, is equal to 0, and we're going to use the OR rule here. For independent events, we're going to use the multiplication rule. Guys, I hope you've got a good idea now of more tools in your toolbox, and you're in a better position to predict what the chance of a future event taking place will be. From me, goodbye.